Welcome back to ZoomInData. As DBT projects scale, performance and cost efficiency become critical for maintaining reliable analytics. In this section, we focus on DBT performance optimization and cost control, where we explore how model design, materialization choices, and execution strategies directly impact speed and warehouse costs. These concepts reflect real production experience and are commonly discussed in DBT interviews. Understanding them helps you build efficient pipelines that scale confidently in enterprise environments. Subscribe to ZoomInData for structured DBT learning, real-time project discussions, and interview-focused content designed to help you grow as a data professional. Let's begin. Why is performance optimization important in DBT? Answer: performance optimization in DBT ensures models run efficiently in the data warehouse. Faster execution improves data availability for reporting. It reduces compute usage and operational costs. Optimized pipelines are more reliable in production. What factors affect DBT model performance? Answer: query complexity and joins impact DBT performance. Data volume and table size play a major role. Materialization choice affects execution speed. Warehouse configuration also matters. What is cost control in DBT projects? Answer: cost control focuses on reducing unnecessary warehouse usage. DBT helps by limiting data processing. Efficient models reduce compute consumption. Cost control is critical at scale. How does DBT help manage warehouse costs? Answer: DBT processes only required transformations. Incremental models reduce full table scans. Selective model execution limits usage. Efficient scheduling avoids waste. What is query optimization in DBT? Answer: query optimization improves SQL efficiency. DBT allows breaking complex logic into layers. Clean SQL reduces execution time. Warehouses process optimized queries faster. What is the impact of data volume on DBT performance? Answer: larger datasets increase execution time. DBT models must handle scale efficiently. Incremental processing becomes essential. Poor handling increases costs. What is model selection in DBT runs? Answer: model selection allows running only specific models. DBT supports tags and selectors. This reduces unnecessary execution, improves performance and cost efficiency. Why should unused DBT models be avoided? Answer: unused models consume compute resources. They increase maintenance effort. DBT performance degrades with clutter. Removing them improves efficiency. How do incremental models improve DBT performance? Answer: incremental models process only new data. DBT avoids full refresh operations. Execution time reduces significantly. Costs are controlled. What is the role of materialization choice in DBT performance? Answer: tables store data and run faster for queries. Views calculate data on demand. Incremental materialization balances cost and speed. Choosing correctly optimizes DBT workloads. How does DBT reduce repeated computations? Answer: DBT materializes intermediate models. Reused logic is computed once. Downstream models reference results. This saves compute resources. How does partitioning improve DBT performance? Answer: partitioning limits scanned data. DBT queries become more efficient. Time-based queries run faster. Warehouse costs decrease. What is clustering and how does it help DBT models? Answer. Clustering organizes data by key columns. DBT queries scan fewer blocks. Performance improves for filtered queries, especially useful for large tables. How does DBT handle expensive joins? Answer. Complex joins are moved to intermediate layers. DBT encourages modular design. This simplifies optimization. Performance improves. How do tags help optimize DBT runs? Answer. Tags group related models. DBT runs only tagged models when needed. Reduces execution scope. Improves performance. What is the impact of full refresh runs in DBT? Answer. Full refresh rebuilds entire tables. It consumes more compute. Should be used sparingly in DBT. Prefer incremental where possible. How does DBT help identify slow models? Answer. DBT logs execution times. Slow models are easily identified. Optimization can be targeted. Performance tuning becomes systematic. How does DBT performance tuning differ across warehouses? Answer. Warehouses handle queries differently. DBT models must adapt to engine behavior. Partitioning and clustering strategies vary. Optimization is warehouse aware. How does DBT help control costs in large-scale deployments? Answer. Incremental models limit processing. Selective execution reduces unnecessary runs. Optimized queries reduce compute usage. Costs remain predictable. What is the role of ephemeral models in performance optimization? Answer. Ephemeral models avoid physical tables. DBT injects SQL directly. Useful for lightweight logic. Reduces storage overhead. How can DBT tests impact performance and cost? Answer. Tests consume compute resources. Excessive testing increases cost. DBT allows targeted testing. Balance is required. How does DBT handle performance regression detection? Answer. Execution time tracking highlights regressions. C comparisons detect slowdowns. DBT teams review changes. Performance issues are corrected early. How does DBT support cost-aware scheduling? Answer. Runs can be scheduled during off-peak hours. DBT avoids unnecessary full runs. Warehouse costs are optimized. Efficiency improves. What challenges arise when optimizing DBT at scale? Answer. Data growth increases complexity. Query tuning becomes harder. Dependencies grow. Careful planning is required. Why is DBT performance optimization important for interviews? Answer. Interviewers expect production-level knowledge. Performance shows real-world experience. Cost awareness reflects maturity. Strong answers differentiate candidates. Thank you for watching ZoomInData. Please subscribe and follow for more data engineering content. If you want more interview questions and real-time project guidance, contact ZoomInData. See you in the next video.